Looking at example 1, part B on section 3.2, I've already graphed the function at least close to what it looks like on the worksheet. Same set of problems that we have to do that we just did for part A. So first thing we want to do, actually let's identify the problem place. So when we're talking about continuity, there's a sort of intuitive definition. If you can just draw the entire function without lifting up your pencil, there's no discontinuities. Any place where you do have to pick up the pencil, that's going to be a discontinuity. So right here, we notice that there's a little hole in the graph right there. I have to kind of pick up the marker here and fill it in up there. That means there's a discontinuity at x equals 1. So the problem place for this particular function is at a equals 1. Okay, so first of all, we want to find what is f of 1, if it exists. That's part A. Okay, so f of 1, remember, f of 1 is the output value when x is 1. So if x is 1, we've got that little dot up there. It's telling us that is the output value. So that's 2. So f of 1 is equal to 2. For part B, we're again finding the limit as we approach from the left. So the limit as we approach 1 from the left. So notice that if I start plugging in values of x that are to the left of 1, we've got just a horizontal line here. That indicates that the function is constant. No matter what value I plug in to the left of 1, the output is constantly -2. So as I approach as I approach 1 from the left, the output values, well, they're constantly -2, so they approach -2. So that's the limit from the left. The limit from the right is part C. So now we're looking on the other side of 1. What happens if I start plugging in values that are bigger than 1? So let's say maybe 1.5. You see if I plug that in, the output is that y value. If I get a little bit closer, then the output value gets a little bit lower. And it seems that it's getting closer to -2. So in fact, that's the same as the other side. So the limits are the same. You can kind of see this because as we're coming in, the y values are they're approaching the same y value, -2, whether I come from the right or the left. So both of these are the same. Now, since they are both the same, that means that if I just take the plus and the minus off, that is, if I'm looking at the limit as I approach 1 from either direction, since these are the same, then the limit itself is the same thing as well. In fact, this is kind of another way to define a limit. If the limit from the left and the limit from the right are equal, then the limit itself is the same thing. So the limit is -2. So notice that the function, the limit is -2. The function value is not that, it's 2. So that is in fact the reason that we have a discontinuity here. So for part E, why is there a discontinuity? Because this is reason 3 that is being violated. The limit as we approach 1 for f of x is not equal to the f of 1. Okay, we saw that that was -2, and then f of 1 was 2, so that's why there's a discontinuity at x equals 1. Okay.